we go. So this evening's presentation is titled NR60 Mk2 and Higher Speed Turnouts, and I'll pass you over now to Matt, if you're okay to go, Matt.
Fantastic. Yep. Thank you very much. Good evening, good afternoon to everybody up in Scotland and those on the call as well. I don't like these hybrid formats at the best of times, so I hope I can see people in the room just about, and I hope people can answer questions, ask questions appropriately, either through the chat or through your host in the room. I will make a start. I've got to correct you first off. I was principal engineer. I've had a tragic demotion, I'm afraid. I was covering a principal role for 2 years, a secondment. My boss was on for 2 years. He's since come back and he's asked for his job back. So that's me, I'm afraid. So yeah, back in my substantive post as senior engineer, but the rest of it all sounds very good, and that's all true. So that's good. So I will share my screen and make a start. So I was asked to present on NR60 Mk2 and the development. So I've added a little bit in there around technical authority as to what we are and who we do. So without further ado, I'll skip over this slide because I think you've covered it already. So senior engineer in the SNC team, plenty of experience throughout NR over the last 14 years. And as you said, 10 years in SNC. So hopefully I know a little bit about the SNC system. And I always like to plug the PWI, which preaching to the converted on this call, I think, but chartered fellow of both institutions, and would encourage others to do the same wherever they can. So I'm going to talk through TA and what we do in terms of the S&C team and how we interface with the rest of the company and what a typical day might look like for me. I'll talk through NR60 Mk2 and where it came from and why, and go through kind of what we've been doing over the last few years. And then I'll talk through a bit more detail on recent and future S&C developments with respect to Mk2, but also things like higher speed turnouts, which are in the pipeline. Questions, I'm kind of relaxed as to whether you pipe up whenever you see something you want to ask a question about, or save until the end. But if I can just ask somebody on the call to watch the chat and watch the hands, because I can't do both. Too much like multitasking for my tastes. So kicking off then, Network Rail's technical authority. Those who aren't aware, we like reorgs in our business. We have had one every year or so for the last goodness knows how long. And technical authority was born from the last modernising management reorg. So we are one of several national functions that operate across the devolved business structure. So our regional business units are divided into 5 regions. So Scotland's Railway is yours, and then there's Eastern, North Western, Central, Southern, and Wales and Western. Along with the other national functions, we support all 5 regions and the routes that are forming part of each regional business unit. Within TA, we are responsible for technical expertise and leadership and strategy. So that's where things like NR60 Mk2 came from. While it's not our core business of providing that technical assurance and expertise, it's a strategy to improve S&C resilience and lower whole life costs. So that's where that one comes in. We manage and assure the control framework. So essentially that means our standards and controls portfolio. So things like our track standards, our business critical rules, and our bow ties that determine how we manage and control risks on the network. We look after the competence framework. So this is how we record and manage people's competence and demonstrate that they are appropriately qualified to do their job. We also look after variations. So when a route or a region wants to vary from an approved control with the appropriate alternative mitigation and controls in place, we will approve that, subject to appropriate checks and balances. And we're also about technical growth and lateral learning, which is, I guess, why I'm here tonight, other than because Greg asked me to. It's really important that we understand and develop the technical expertise across the room, across the routes and regions, so that we can share what we know and we don't keep people in the dark. So we're all about spreading those networks and communities of practice to extend what we all know. And the aim of the game really is in supporting our routes and regions to be better, safer, and more efficient in what they do. And ultimately, it's putting passengers first, which is another one of our taglines. Everything we do in TA is aimed at supporting the routes and regions in providing an excellent service for the paying public at the end of the day. So within the S&C team, as part of TA, we're lucky that we have a very varied role. I won't go into each of these bubbles now because I could talk about each one of them for an hour probably. But I'll just talk through a couple of these photos. These are some of the examples of work we're currently involved in. So the regulator, so the Rail Accident Investigation Branch, are part of that organisation, and they're the ones who hold us to account when we don't get things quite right. This is a really good example of this in recent years. Is the derailment down at Eastleigh, which some of you may be familiar with. This was where some track fastenings failed in service under a train, unfortunately led to a fairly severe freight train derailment. This was something that we were obviously quite interested in and making sure we didn't have to suffer that again. So a big piece of work has been going on in the last few years, looking at the technology that we used in that fastening system and whether it was appropriately specified, appropriately designed, and whether or not we could optimize and improve that design. So it's a piece of design work we've been doing with Progress Rail recently to optimize that system, and we're going through some testing now to validate those changes. Routes and regions. So this is basically, as I said in the previous slide, it's supporting our regional business units. An example of this is Smart S&C, and this is an example of the Connex system, which we're currently engaged with trials on our infrastructure. So this is essentially a very fancy void meter, and the sales engineer told me the other day in a true M&S sales pitch, this is not just a void meter. This is a very advanced algorithm-driven system, which will allow us to predict and prevent failures in the track asset. So we are supporting the routes and regions in their technical strategy to be as good as they can be through novel infrastructure. Maintenance teams. So bottom right, this is an example of an NR60 Mark II crossing, which is not as good as it could be, perhaps after the 6 months in service, I think it was, after I took that photo. So we were approached by the routes to say, you know, we've installed this new asset. Why is it doing this? It's not very good. We expected better. So supporting them with track inspections and trying to do some root cause analysis for how that degradation might be occurring and whether or not we can do anything within the design or the maintenance of the system to improve that. And then bottom left is a nice picture of our tilting wagon fleet. So this is representing all the things we do with route services. So there are internal supply chain colleagues who buy and deliver all sorts of materials across the infrastructure, so S&C particularly, and this is the tilting wagon system that's used to deliver S&C to renewals across the country. And it's just an example of one of the many areas where we're technically involved with supply chain to improve and optimize those rail delivery systems to make sure we're given the best value for money we can from a technical standpoint. So I'm going to talk quite at length about NR60 Mark II because it's been my day job for about 7 years now. So some might say that's a bit too long, but I'm really passionate about what Mark II means for the industry and what it can do and what it can't do. So forgive me for talking about a labour of love here. So going back to the first principles, why have we done NR60 Mark II? Well, partly this is down to the legacy of SEN 60 S&C. So Idiot's Guide to Rail forms. On the right side there, you've got 56 in the red outline and SEN 60 in the green outline. And as any structural engineer will tell you, a taller, stiffer I-beam section will transmit loads better and last longer and generally perform better under high category traffic. So it sounds simple, but how do we get it so wrong? Well, it has got a really painful backstory. And part of this dates back to the RT60 legacy. Railtrack, in their wisdom, introduced what they termed RT60. And rather than owning that development themselves, they put it out to market and said, okay, here's the spec, go away and sell me some RT60. You can choose what it looks like within certain parameters. And the market said, great, here we go. 4 different designs, 4 different manufacturers, regionally, broadly a spread between regions as to where it went, but not exclusively. So we do have some patches where we've got a mix of all 4 of these legacy items with varying degrees of success in maintenance and spares and OEM support, which gives us, you can imagine, quite a maintenance legacy, quite a nightmare really to look after. So That was the early days of RT60, and if we were in the room now, I'd be putting it over to you guys and saying who can identify the 4 manufacturers from those photos, but I'll skip that because no one can ever do it anyway. So we'll move on. But it just shows the challenge we have with our legacy from Sen60. We then implemented NR60, which was one of these designs. So the bottom right design there, we bought the rights to that and rebadged it NR60, which helped a bit, but we still had some challenges with implementation, with the cost of installation, some early reliability issues, and we'd found that uptake of Sen60 S&C had tailed off. And if you want to understand why, you have to go all the way back to the Railtrack era and look at what we were doing. So for all their faults, Railtrack were actually very ambitious with their track category specification. This is the equivalent of 2102 track standard from back in the day, and it specified Sen60 S&C all the way down to track Cat 3, which surprises a lot of people, myself included, when I dug this out. So that's why we have so much of it out there, because we were really pushing this hard. So all of the West Coast mods and similar major programs that were going on in the noughties were subject to this kind of specification. Moving on and introducing NR60, as I said, standardizing on that one design. The cost of implementation of that was quite significant, which I'll go into the reasons for that in a minute. So in 2010, we were under a lot of pressure on unit rates and costs. So we relaxed that specification to Sen 56 for the shorter switches, which was only ever meant to be a temporary measure, which I think people had forgotten. So that meant that actually Sen 60 was only really required for the longer switches. So we could put in really high category track using vertical shallow depth S&C, which is not really rated to the kind of tonnages that we were putting over it. So that was about the same time we started working on the revised Sen 60 design, which commenced prototype testing in 2016 with our first installation the following year. And this is First North. So this was the first NR60 Mark II site installed. And then we had subsequent sites in 2019 with full system approval granted between the two. And then finally, the big win, the kind of the end finishing flag, I suppose, in the system in the design updates was to get 2102 rewritten. And again, this was a battle because we were rewriting all of those temporary rules. We were increasing unit rates again by reverting back to what should have been in place from the early noughties and putting in NR60. We didn't quite get it as far as Cat 3, but it's now NR60 as standard for Cat 1 and 1A, which is a massive win for us. It's a challenge sometimes for the projects and the routes to accept that, but from a whole system perspective, it's the right thing to do. So a little bit on the development process. The philosophy, we were about making NR60 Mark II lower cost than its predecessor to improve the uptake and to demonstrate value for money for customers. We needed this to be more reliable. There were some teething issues with RT60. There were some early teething issues with PoE on NR60 Mark I. So we had to get this right out of the box. We had to maintain footprint compatibility with Sen 56. So one of the reasons for Mark I being more expensive was that the geometry adopted on NR60 Mark I was different to what went before, different to the full depth vertical that was in the ground, what we were replacing it with, which meant that when you install NR60 Mark I, you often had to move overhead lines, you had to move signals because the curvature of the turnouts weren't compatible, which made a massive increase in cost, because as soon as you got to involve overhead lines or signaling in a track renewal, as I'm sure a lot of you know, that increases the cost a lot. And obviously we had to improve safety and performance wherever we could. So geometry was the first step, and it was all about achieving compatibility and reducing some of the issues we'd identified with the higher speed turnouts on Mark I. So this chart shows you the comparison between our Mark I layouts in orange and the Mark II layouts, which are closely mapped to the 56V in blue. So the idea here was maintaining compatibility and giving us the maximum optimized operating parameters without exceeding any of the recommended rule sets from the Euronorm. We'll talk about that a bit more when I come on to the high speed 2 geometries, but broadly speaking, because we were aiming to replicate the footprint of the 56V, vertical S&C, it meant that the curvature was reduced, and the additional capacity that you get from going to a NR60 section is kind of in the bag. We've got that in the back pocket so that we're not designing this right to the wire, whereas Mark 1 was designed right to the wire to maximize capacity and capability. But actually, that can lead to challenges with maintenance. Running the asset at its limit rather than having a bit of headroom. It also means that any kind of curvature that you put into the unit by putting on a mainline radius, for example, you're exceeding your curvature rules quite quickly on a Mark 1 layout, whereas 56 and 60 Mark 2, you have a little bit of headroom to support to the flexing of the layouts. In terms of reliability, we sought funding from our central IP development team, as it was at the time, to build some trial panels and really put these through their paces. So we built 3 of the most common switch sizes, and we really played around with drive positions, PoE types. We trialed 2 different PoE systems. We instrumented the panels up, and we put drive units in different places up and down the switch. So we had the capability to move these drive units up and down the switch to assess switch flexure and obstruction detection in terms of getting headroom as good as we could get it. And we also demonstrated that NR60 S&C could be reliable with a mechanical back drive. Again, this is about making unit costs as low as we could reasonably get them. So we identified that mechanical back drive was fine on short switches and flat layouts, but not so good on the longer switches. We also canted the switch, so it's hard to tell, but this is canted at 150 mil to straight. So we were able to do that and demonstrate that there is a bit of a sweet spot in terms of operation of PoE. So while you can put an E-switch on the cant at 150 and just about get it working, it's not reliable. And the data we've got is invaluable now in having those conversations with routes when they're specifying S&C in terms of what they can do, what they should do, and what they can afford to do. So a couple of examples here of some of the traces we got. So here we go, cant at 150, so the blue trace, we're canting it at 150, that's this layout here. And if you compare the peak pressure to the stall point at 100 bar, you can see that when it's going down the hill, as it were, they're broadly comparable, going normal. And when it's going up the hill in terms of reverse, when you've got it on the cant, you're very nearly at your stall point. So this system is designed to fail, really. Whereas with it on the flat, you've got sort of 15-20% headroom. On the cant, you've got almost none. And those kind of arguments really allow us to build up the reliability picture and to make sure that people are making the right decision with the information they've got. And that's led to a lot more switches going in with high drive than we would otherwise have had with a mechanical back drive being a blanket approval. We also messed around with toe opening as well. So in terms of mechanical advantage, NR60 systems need a 60 mil opening at the rear, whereas 56 is 50 mil at the rear. And we were experimenting with opening up the switch toe more to deliver more opening at the back. It seemed like kind of basic mechanical advantage type stuff, but this had never been done before. And by doing these investigations, we were able to demonstrate that the decision was robust and had evidence behind it, which led us to making the right development options with the PoE teams as well, making sure that we were doing that as a whole system rather than just doing it in isolation. Crossing design, we did a lot of work with our development partners, Progress Rail, who are, I think, all on the call, so I need to be nice about them. In terms of crossings, this is a kind of a whole systems redesign. So we took this kind of top, middle, and bottom approach to the cast crossing. So looking at support stiffnesses and bearer spacings to optimize the base of the crossing and the load transfer. Working with Progress Rail to optimize the internal architecture of the casting. So this is about stress transfer and mitigating against stress rails wherever we can at change of section and the internal pockets. And then the top in terms of wheel rail interface and load transfer between the crossing nose and the wing, and optimizing that, working with the universities, including University of Huddersfield, to tune that and to tweak the millimeter changes in the topping can have quite a big impact on the crossing performance. So some of the conclusions from the FEA work were around beefing up the structure, changing the internal pockets, and making the the change of section optimized using FEA. And all crossings are now 20 mil continuous foot flange and explosively depth hardened as well, to just to make them as robust as we can. So systems wise, approval and assurance was done by our team with support from an assessment body. So this is following the common safety method. This was clearly a very significant change in terms of novel S&C systems and novel POE. So that was all done in line with the CSM approach. The geometry was undertaken by an external specialist and supported by us using Excel calc sheets and self-checked by CAD and the BRT interface as well. It's quite useful that these are almost self-checking in a way. If we develop an S&C system that is not geometrically compatible with 56V, the designers are very quick to tell us that it won't fit. And this is where we end up with this term compatible with rather than identical to. It's not possible to have an identical system given the gauge is tweaked slightly. So it's all about making sure we're compatible within reason. There have been issues where we've not been able to put in Mk2, where there's been things like non-compliant follow-on crossover lead lengths. But where we're able to do like for like, we are normally able to do a Mk2 upgrade. So feedback and performance to date has been very good. Couple of case studies here. First North Junction, which I've already mentioned, was the first one installed, and Ulceby was a couple of years later. These two were selected. First North being straight, quite high tonnage, but mostly fast passenger traffic on the straight. So lots and lots of impact loading, lots of high speed moves. Whereas Ulceby Junction is the opposite end. It's much slower, but it's incredibly heavy tonnage. It's a couple of miles down the line from Immingham Freight Port, so it sees loads and loads of loaded container wagons and aggregate as well. I think it's up at about 100 million gross tons per annum, so it is one of the highest category lines in the country. So case study 1 is Thirsk, and Mk2 was installed north of the station, and 56 was installed south of the station. That wasn't deliberate, that was just the way the renewals happened to work, but it's given us a really good benchmark. So looking at the maintenance and service history since the installations, Thirsk South has had a litany of failures, culminating in a broken crossing after only, I think it was about 2 years after installation, which is obviously disappointing. We wouldn't expect that from 56, but it kind of shows that the 56 system isn't really capable of the traffic that we're putting it through. Mk2, the maintenance history is quite different. To date, we're not aware of anything other than minor lipping and grinding correction for that minor plastic flow that we get on crossings and switches as they wear in. So that's a massive success story and clearly speaks volumes about what we've done in terms of boots off ballast and access constraints, which we're struggling with. Case study 2 is Ulceby. So yeah, it's a very heavy freight route. I can't underestimate that. It's 100 million gross tons per annum, as we said, which is about as heavy as it gets on the network, and was a timber layout before with all sorts of things wrong with it. Multiple crack crossings, 5 crack crossings in a 6-year period is any maintainer's nightmare. And since renewal, it's been holding up really well. So the geometry traces shown there, you can almost not see the crossings, which is quite incredible after the time it's been in the ground, which is really good news. And a bit of feedback there from 2 TMEs who've been raving about it, which is really good. So in terms of challenges and where we are now, we're sort of 4 or 5 years down the line from the early installs. In terms of what we're learning, mostly it is becoming BAU, business as usual for our routes and regions. There are some pockets of the network which are still struggling with the novelty of it. But the biggest challenge for us has been familiarity with the system, briefing, training, going back to the kind of competency framework that I spoke about earlier. This is stuff that we aren't very good at, I don't think, in Network Rail, particularly around some of our staff and our retention of staff and retention of that competence and knowledge. So that's been a real challenge. A lot of what we do has been the same for generations, literally. You know, Pandrol clips, the main example of change here that we've implemented. We're using Voslo clips in Mark II for the first time, as opposed to Pandrol, which have been around since the day one of the railway. And that is more of a challenge than you would expect to deal with in terms of tooling and inspection and competencies. So there's a lot of stuff there, soft skills stuff that we need to manage. So it's learning to treat the change of the project and understanding that you can't just hand over a new product and say, here you go, get on with it. So it's about embedding that and giving people the tools and skills to allow them to maintain and operate their stuff. We're also learning more recently that NR60 Mark II is not a magic bullet, unfortunately. You do still need to maintain it, which a lot of people are disappointed to hear. We have had some failures now. Upsettingly, we've lost our infinite mean time between failure because we have had some issues with switch lipping causing points failures. I should add that this is often in cases where we are not put our track lubricators back on, which is a bit of a head in hands moment from a central perspective. That should never have happened, but it did. And there's, again, it's competence and it's understanding that putting this in and forgetting about it isn't the answer. It will perform better than what you had previously, but it is different and it needs different care and attention. In terms of embedding the system, the design interfaces with BRT have been a bit of a challenge. The BRT register files that go alongside the layout design registers in BRT, we've had to update those, which is not something we were massively confident about doing. So that's been a bit of a learning curve for us. There's a slight geometry quirk on the C switch, which means you can't actually have a BRT register file for it, which doesn't seem like rocket science to me. It's perfectly possible to design C switches without a BRT file, but the number of times I've had designers tell me, oh, I can't design a C switch here because I haven't got a register file, because I think people have got quite reliant on those. So that's a bit of a challenge for us in how we manage that. Fastening system I've spoke about, that will always be a challenge, and I'm still getting feedback saying, well, why haven't you used Pandrol? And we did that deliberately. So the Pandrol system is very good, but it does require significant ergonomic challenges with pulling clips in, and also significant safety issues with hitting them out with hammers. And we all know that you shouldn't unclip with a hammer, but you do, and if you can, someone will. And moving away from this to a controlled, torque controlled fastening that uses power tools to install rather than hanging on the end of a lever has got to be the way to do it. And that's a difficult journey that we're on, because that level of change hasn't gone down very well, and people are resistant to change and they don't know it. So we're ongoing with that one. Material lead times have been a challenge. So again, change is difficult, particularly with central route services and the way they're set up to buy things off a menu. If the menu changes, they run around like headless chickens and aren't quite sure what to do. So again, there's challenges there. And then it's publication of standards. So lots and lots of standards are affected by the Mark II change, and we are slowly working through those. Most of them now, I think, have been done, but there always seems to be something someone will point out saying, oh, this doesn't say Mark II, what do I do for Mark II? And there's dozens of standards out there, and we do need to work through the process to get them all up to date, and that will be a program of probably the next couple of years until we get through them. 1 second while I take a swig of water. So moving on to a more relevant and recent development. Hopefully some of you are familiar with this location just outside Glasgow at Uddingston. We were approached by Scotland Route about 3 years ago, who had a renewal of this junction on the West Coast Main Line. This is kind of classic NR60 Mark II territory. So high tonnage, high speed, reliability, critical. And they wanted to do it in Mark II, which is great news. Only we didn't have an H switch, we hadn't done any double junctions, and we hadn't even thought about a switch diamond. So in theory, yes, let's do it. But actually, oh dear, what do we need to do? So we got to work on a design for that. The main thing we had to challenge here was this perception that switch diamonds are unreliable, because they are unreliable. They're horribly unreliable. Our existing mean time between failures on switch diamonds can be as low as 6 months with HW machines, or slightly better with clamp blocks. So we had to challenge that and kind of redesign the diamond from the ground up, which me and my team did. We understand this was a European first of type. Europe don't seem to use switch diamonds on high category track. They tend to build long junctions and flyovers instead. Lucky them. We unfortunately do not have that flexibility and freedom. So this was, like I say, kind of ground up engineering for a switch diamond in terms of what it needs to do, how it needs to behave, copying as many of the Mark II principles as we could, but thinking outside the box slightly where we could and where we needed to target the diamond reliability elements. The biggest problem with diamonds is thermal reliability, as this wonderful bit of animation will show you. When a diamond gets cold and it stretches, you tend to get the knuckle spreading apart, and when it gets hot and it squashes, you tend to get the knuckle pinching in at that point. And that's unavoidable when you have a system of rail that's expanding and contracting, and it's unavoidable when the system is designed to not be thermally resilient. So looking at your classic switch diamond, you've got stretcher bars in 4 out of 5 beds at the knuckle. You've got the knuckle bed, which is too narrow to tamp. You've got the full depth rail section, which you've machined half the foot off. And it's hardly surprising, really, that this system isn't very good in hot weather. So the starting point for this was we had to have a fully tampable, fully ballastable solution, which required us to kind of reinvent this from the ground up, looking at the PoE systems that we had. We needed to do away with stretcher bars in the beds, which are shown there, to allow us to fully tamp those beds and to provide maximum stability, which required a totally novel PoE system. So stretcher barless PoE system on the bearer rather than in between bearers, and a prototype and testing program which allowed us to put this through its paces, similar to what we did with the early switches. We did the same approach with our switch diamond. So spent a good few months pulling this apart, putting it back together, trying to break it, understanding the limits of the PoE system and optimizing the toe opening. This is all designed around making the system as robust as humanly possible. So we've got things like a strap rail, which we've had before on diamonds, but we've never blocked them across. So the strap rail is reinforced across to the wing rail in several locations. The switch rails and stock rails are bolted through as well. We've got thermally resistant PoE systems. So when the switch rail moves thermally, the PoE tolerates that because the drive connections are slotted. And we've put in much more robust switch rail and stock rail brackets to support that system. So that's been kind of the last couple of years worth of development work in terms of getting the diamond to where it is now. And that culminated in a Christmas installation last Christmas, so Christmas 21, with what was some significant stakeholder management for me and a difficult conversation with the family. Just so you know, I'm going to be out at Uddingston over Christmas. I hope that's all right. Which I'll let you form your own opinions as to where I would rather have been, but this was a good few days driving back and forth between those two locations. And there it is. So this is Uddingston Junction, the diamond part of it, and there's the switch diamond in the ground. And you can see there comparison with a typical switch diamond. This is fully tampable at the knuckle, which is first for us and massively beneficial in terms of system stability and thermal performance. The last year I've been on tenterhooks waiting for something to fail, and so far I've been luckily not in Scotland dealing with failures, which is really good. So we've had one service affecting failure, which was down to a roller cage being left untightened up, and it came loose and got trapped in the switch, which is disappointing, but it's a human factors thing. These things happen, and we can't always avoid them. But I think one service affecting failure in 14 months compared to what would have been probably several failures a month previously is really good news. The PoE system is running at approximately 50% headroom, which again is better than we could have hoped for, and comparable with the kind of test results we were getting on the yard as well. So good to know that whatever we've done in an ideal situation in the yard in the controlled environment is replicated on the track as well. So next steps, and the next steps for me have been the same for the last couple of years, and it's about rollout and confidence and BAU and making this a standard tool in the S&C specifiers toolbox. And I think we're getting there. I think for some reasons, Scotland and Eastern region are both really far down that journey now. Most of what goes in on the high category stuff now is NR60 Mark II, which is really good, and even down to the lower category as well. Other regions are just starting on that journey and are a bit later to the table for various reasons. So we are working actively with them to improve that uptake. Tooling and competence remains a challenge in the wider framework of competency management and how we look after that. I don't think that's going to go away anytime soon, and it's something we're actively working on, not just for Mark II, but for S&C as a whole anyway. Just little things like, is there a competence to change a half set? You'd be surprised there isn't, which is odd to me when it's such a critical job and such a huge number of things that can go wrong with that from a reliability and a safety perspective. Whereas if you look across the fence at what signalling are doing, you can't even touch POE unless you've got the ticket for it. So I think we've got some lessons to learn. We've got some development to do on that front. As I said earlier, first failures, unfortunately, is not failure free. So we've had a couple of sites now where we've had defects caused by, I don't think they're design related. Some of them are probably still too early to tell, but following up on the early failures and seeing how they bed in over time. Extension of the range, so moving to double junctions and hopefully more switch diamonds. We've got another switch diamond in the order book for next Easter, which is taking up some serious thought at the moment because it's a 1 in 8 rather than a 1 in 21. So it's the opposite end of the scale in terms of geometry from what we did at Uddingston. And also looking at alternative POE. So again, it's a regional thing. A lot of people on Western region particularly like HPSS. Other people run a mile when you mention it. So we've not implemented HPSS yet, but it's on the cards and we know that people want it. So as we go further into BAU and embedding this, we'll be looking at alternative POE systems as well. Which brings me nicely onto the next challenge, which is higher speed S&C. This is to interface with HS2. So this isn't HS2's switches, this is our switches, which will allow us to turn off at places like Crewe and just outside Birmingham and run from the classic NR infrastructure onto HS2's lines. This requires turnout speeds of 100 and 125 mile an hour, which is not something we've got in the current portfolio. And both of those will require swing nose crossings, which we've previously implemented back in the 80s and 90s. And I think it's fair to say didn't do a very good job of it because we put them in and then swiftly took them all out again because they were unreliable. So a big piece of work there, looking at extending the range from Mark II to include swing nose and longer turnouts and higher speed as well. So we're working with a development partner, Voslo UK, and their French counterparts who are supporting this because, high-speed S&C is not our bread and butter yet. It will be, but at the moment we are learning from our European counterparts on what that looks like and how to implement it. So this will be a range of S&C, so I switches and J switches, which are huge. I'll come on to that in a minute, which will allow us to leave and join the infrastructures at those higher speeds. So swing nose crossings, and because of that, we need novel POE again. So we'll be going around that loop again of looking at POE that can do slightly more than what we can currently do with our existing range. So the piece of work is funded by HS2 because their business case doesn't work if they can't run on our track. So fair enough, they're paying for it, and they are the number one gold-plated client. But these benefits, if we can standardise this, will be felt by others as well. Things like Northern Powerhouse Rail. I've even been approached by a Wales colleague who wants to implement a 100 mile an hour turnout. I'm not sure why they need that in Wales, but we'll see. But the intention is that this will be a standard part of the design portfolio off the back of HS2's funding, which is good news for us, and will hopefully mean that we can increase capacity and capability of the network across the sites where enhancements might be required. But we won't be able to do that because the existing portfolio is limited. There's also a benefit in swing nose crossings more generally. Short crossings, particularly short crossings on high-speed routes, do not perform very well, and the reason for that is they're not really designed to. The impact loading on a short crossing at 125 miles an hour is significant, and if we can improve that by providing continued wheel support in the form of a swing nose crossing, clearly the asset's going to last longer. In terms of the geometries here, we've taken a lot of learning from Europe and also from our existing Mark 1 range and some of the issues we've had with our fastest turnouts on the West Coast main line, particularly around passenger comfort. They've not performed particularly well. We've had to speed limit the H switch because it exceeds the Euro norm, and it's had some fairly serious rough ride issues in the past. So the H switch is actually now speed limited to 80 to prevent those issues, and we need to effectively redesign the H switch and also the I and the J to rectify those issues. We've done that through changing the toe geometry. So while NR60 Mark 1 and RT60 does have a clothoid at the toe, it's almost too short as to be effective, and the train barely sees that clothoid, that spiral feature. So it's effectively an instantaneous change of radius, which gives you a significant lateral loading and accelerations, which the passengers don't tend to like. So we've implemented what we're calling true transition, i.e. a transition element that has a significant length that allows us to ramp up to the switch radius over a sensible period to bring that rate of change of cant efficiency or jerk value down to a more sensible level. So going back to my original interface slide, it's a difficult one, this one. The number of people involved in high speed turnouts is vast. Not just HS2, who are, as you can expect, a very, very demanding client. We've got all the interface people on the route and the region who would normally be dealing with a typical renewal, as well as your designers, contractors, manufacturers. We've gone truly European here. We've got French S&C and Italian POE, which is leading to some challenging conversations, really interesting work, but quite difficult at times. Hopefully some more exciting site visits than Uddingston, we'll see. We're learning from HS1 as well. They've been doing this for 15 years or so, but I think it's fair to say that Handsacre Junction on the West Coast Main Line is a different world in terms of tonnage and traffic to what High Speed 1 have to operate. So I think while we're learning from them initially, it won't be long before we're already ahead of them in terms of tonnages and maintenance liabilities and the challenges associated with that, and running a true mixed traffic railway. From what I can tell in Europe, they don't run high speed and heavy container freight on the same tracks, whereas we like to be different and we'll be doing just that. So it will be interesting to see how these things hold up, because we're putting them through their paces in a way that hasn't been done before. So yeah, it's still early days on that, and I think it'll be an interesting couple of years, and I'd like to come back and talk to you a bit more mature on that journey. We've only just started really, but the design principles are true transitioned toe geometries. So as I said earlier, having a proper transition in there to take you from the straight to the switch radius. Swing nose crossings, because our crossing angles are 1 in 30 up to 1 in 50, depending on the speed and the geometry of the crossing. POE reliability, so new systems to accommodate swing nose operation, and also the long switches. We're not comfortable operating our existing POE at those higher speeds and higher tonnages, so we're looking for full system POE off the shelf from Europe, rather than the mix and match approach we've had in the past on the UK infrastructure. Generally speaking, following the rules from Mark 2, but with elements of the French designs creeping in, where what we have in the UK or available on the shelf doesn't quite meet what we need to do. The biggest challenges so far have been around logistics. So I think our I switch is 60 meters from toe to heel, which is it's almost double what the current longest switch is, which is clearly going to be a challenge to lift in and out. That's a major piece of work that we're looking at with our route services colleagues to how we handle that. Swing nose crossings really need to not make these have the same reliability issues they had on the West Coast 20 or so years ago. These have got to be ultra reliable out the box, and that is a challenge for us, I think. Maintenance philosophies, again, learning from Europe and learning from HS1 is difficult, because no one's running the tonnages that we're going to be running on these. West Coast Mainline South is sort of 60, 80 million gross tons per annum. And I think last I heard, HS1 was about 15 or 20, I think. Someone's going to correct me on those later, but thereabouts. We're running at about triple what HS1 is running at. So it will be a steep learning curve if we get it wrong. As you can imagine, the tabloids are desperate for this to fail. If you imagine day one, West Coast mainline shot, HS2 shot, we're going to look very silly, and we need to be absolutely sure what's not going to happen. The fluid program bit is also bugging us slightly. We keep being given dates for when the first junction is going in, and they keep changing. As you saw on the news last week, HS2 doesn't know what they're doing, doesn't know when they're doing it, but we have to work within that fluid program and try and deliver what we can within the timeframes we've got open to us. So yeah, this is a big piece of work, and it's going to be exciting, I would say, but also very, very challenging. And that, I think, brings me to the end. I think I've slightly overrun the 45-minute slot, but yeah, just wanted to say it's a massive team effort. I'm speaking here on my own tonight, but this wouldn't be possible without the rest of the S&C team and the supply chain partners. Special mention to Progress Rail, who are in the virtual room, I believe. They've been key development partner from day one on NR60 Mark II, and they've done some really good work on this. And you know, countless other people, designers, contractors, installation teams, anyone and everyone. This is sounding like an Oscar speech, so I'm gonna wrap it up. But thank you very much, and I'd be keen to take any questions that I can answer.
Thanks, Matt. That was excellent. There's currently no questions in the chat, so if anyone wants to either drop one in there or equally come off mute or in the room, you can ask one. But if I could maybe just kick off and ask you something to get us going. Just interesting, you mentioned the even bigger switches that we're developing. I was just wondering, are you looking as part of that development, are we looking just now at how they would be able to be transported and installed as part of the design? Because obviously that's a big challenge, and given that
it is, yeah. So we've been careful to manage our scope. We're a very small team. There's only 2 of us really working on this piece of work at the moment. And while we're developing the S&C, we aren't route services. We're not responsible for driving things around the country. But clearly we need to have some input, and we need to support that activity, which is exactly what we're doing. So route services are leading on that piece of work. They're developing some new rail vehicles that will carry, essentially, these are going to look like long welded rail trains, because that's what an I switch or a J switch looks like. 60 to 100 meters in length. They're not going to be craned off the back of a low loader. They're going to have to be rail delivered with some bespoke equipment. And alongside that, there's some logistical challenges around what we provide in terms of craneage and access at sites, clearance into OLE gantries, all sorts of questions. The OLE design for Handsacre Junction has had to be changed to accommodate twin track cantilevers rather than portals, so we can get these things in. So yeah, these questions and conversations are going on, but we're careful that we're not leading the development of that solution. We're just supporting. But yeah, it's in hand. And then when it comes to lifting the things, it'll be a couple of Kirovs and some mighty big lifting beams. And I hope, because the weight shouldn't be too significant, but the size is, I would hope that should be sufficient to help us to offload from the rail wagons onto the track.
Is the current preference still to move away from modular then?
For higher speed, yeah. Because these are turnouts rather than crossovers. If it was modular, it would have to be spine panels. We wouldn't want to operate a swing nose crossing with spine panels. I think there'd be an argument to say you could do the guts, the closure areas and the heel with modular, but because you can't modularize the switch and you can't modularize the crossing, you're limited in what you can do. But I think it's part of the toolbox, but I don't think we really want spine panels on a modular turnout on high speed 2 interfaces.
Okay, cool. There's a question on the chat there from Stuart Corey. He's asking, does NR60 Mark II design work in an equal split arrangement?
Yes, yeah, it can do. Yeah, we haven't done anything that would preclude that. I don't think we've done any yet, but yeah, no reason why it shouldn't.
Question for the back of the room, Greg.
Yeah.
I've got 1 or 2, but I don't want to bog the show.
For as long, hopefully they can hear you from there, but should they?
Right. You mentioned quite early on in your presentation, NR60 Mark II, that you manage the confidence of the staff. Is that a moderated self-assessment, Or is it a proper competence assessment against a recognised standard?
Yeah, really good question. And I will have to take that one away because the way this sits within our existing competency framework, we have two competencies, TR0101 and TR0102, which relate to S&C systems. So we've amended those to include some Mark II fastening system stuff. But in terms of NR60 Mark II as a standalone competence, we have kind of followed the precedent of what we have already, which I agree is a little bit thin. We don't have 56V competencies, for example. We rely on kind of time served competency with a small c and familiarization. And we've tackled this with local briefings and with guidance notes. But yeah, it's not as robust as I would like it to be, put it that way.
Another one, you mentioned again quite early on that SEN 60 versus SEN 56 S&C. What science exists to back up the claim that SEN 60 somehow transmits the loads better and lasts longer when it's round about the same in head width, slightly longer than in the web, and the foot's not that desperately much wider?
So this is about the support conditions as well, and the fact that the standard SEN 60 system uses 600mm or 650mm bearer spacings versus the 710mm bearer spacings in 56. But it's also about the bending moment and the fatigue of the crossing elements. So taller section, stiffer section, therefore better in stress and better in fatigue.
I was particularly interested in the lasts longer. Apart from the ADH part of it, lasts longer in terms of headwear or
Lasts longer in terms of fatigue performance. So that's more relating to crossings because they tend to be one of our pinch points on S&C. So the SEN 56 system being sort of 15-20mm shorter doesn't perform as well as the SEN 60 crossings. That we know that from evidence from Mark 1. So Mark 1 crossings perform better than 56 crossings based on that more robust structure and transferring the forces into the ballast better with more regular, more even bearer spacings means that the ballast deterioration and foundations are more robust as well and generally have a better fatigue performance and slower degradation rate. Again, this is kind of it's established science that the SEN 60 track is generally good for more tonnage, and a lot of our network modelling is based on that. I think it's 800 million gross tons per annum for SEN 56 as a rule of thumb, and 1,000 million gross tons per annum for SEN 60. That's in our S&C strategy policy documents.
So it's not necessarily the real section, it's the bearer spacing, which more or less.
Yeah, it's both. It's the whole system. Yeah.
A question then about Thirst Junction that you mentioned specifically, the SEN 56 crossing failed and the SEN 60 didn't.
Yeah.
Were both crossings EDH hardened?
Yes, there were. Yeah.
Okay, and in terms of failures, what kind of analysis do you do to make sure you attribute the cause of failure to design, material, or installation quality?
So for Thirst, we were really lucky in that they were installed within a couple of months of each other by the same installation team. The crossings were from the same manufacturer and had been subject to the same traffic and same maintenance regime. So that was a really useful test case. Obviously, there are a huge number of variables when it comes to crossing performance, and we all know that voiding and maintenance of crossings isn't always as good as it could be. I don't think I'm giving away any state secrets by saying that. But what we do know is that where we have a lack of access, the more robust system will last longer and perform better because it's more tolerant to those kind of failure modes. Obviously, we get dip angle traces from our geometry trains, so I'd be able to look back at Thirsk South and almost guarantee that the dip angle measurements for Thirsk South versus Thirsk North for a similar period of operation would be very different because they don't have that optimized topping and they don't have that optimized support condition either. So yeah, it's difficult. We don't take away every crossing and do a forensic analysis on it. We're just not resourced to do that. But we can piece together a picture based on maintenance history, repairs that have been undertaken or not undertaken, data from geometry traces, and build a picture of how it's been looked after and how well it's lasted given its maintenance.
And maybe last one for me, you touched on French design.
Yep.
Why was Mark II developed rather than go straight to the continent and get proven off-the-shelf design?
For higher speed or for
For
our
anything?
general?
As a policy, as a strategy.
Yeah, okay, fair challenge. I mean, for Mark II originally, we did take some European learning. Because we were working with our UK supply chain, we didn't want to just jump straight to supplying all of our S&C from a European supplier. That would have just been too big a challenge to take on, and probably commercially, I don't want to speak on behalf of C&P colleagues, but I'm sure we wouldn't have been allowed to do that anyway. We took a lot of learning from Europe, so the SKL Voslo fastenings, which are not used in this country but are used exclusively across Europe. Other elements of design, so we've pinched all sorts of design from across Europe. We've done some stuff with crossings as well, nicking ideas from SNCF and Infrabel. We have implemented some changes to how we manage stressing and stress transitions and stress monitoring in the toe from a French design. So yeah, we have done all of that. We just haven't bought it wholesale as a single item. I think because we want to retain some element of system ownership as NRTA, we wanted this to be NR60 rather than French 60, for example. We didn't want to buy a product and have it not perform that well. We are the S&C experts in this country, so we thought we were good enough to do that. And we know that from RT60 days, it wasn't the most successful solution to put out a spec and buy something off the shelf. You could argue that the spec wasn't quite right, which I don't think it was, but that was effectively that. We had Voslo, we had or Chorus as they were at the time, and we had VAE, both significant European operators who sold S&C, and it wasn't all it was cracked up to be. So by taking a wholesale ground up approach and trying to optimize and design this stuff and design out the failure modes, I think we've got a better product out of it. It's interesting now that we're doing HS2 high speed turnout stuff. We have gone for more of the buy it off the shelf in terms of we've asked Voslo France as our development partner to design it for us to the NR60 Mark II principles. And it's a bit of an interesting hybrid of a French design and our design, which again, we are taking a really close interest in. We are obviously going to build switch test panels and swing nose crossing test panels and work really closely with the manufacturer and the development partner to test those. The other thing to bear in mind is that actually the overseas systems haven't got a great service record. If you speak to HS1 candidly off camera, they'll tell you that the reliability of their infrastructure is not as good as it could be or as good as they would hope. So yeah, there are learnings to be had from across the water, but I don't think buying it off the shelf is necessarily the best solution, and I don't think it would be a perfect product out of the box. I know it wouldn't be based on the feedback we've had from HS1. So I think this gives us kind of the best balance of both worlds.
Sorry, I was going to ask my last question. It wouldn't be fair, but that's a sustainability question. Have you done any exploration of alternatives to concrete bearers for S&C?
We're looking at alternatives to concrete within the classic S&C network. We don't think the appetite is there for the risk on higher speed turnouts. It's something that we may get to in the next 5 years or so. Obviously, you're probably aware we're trialing composites for planeline, and I see composites being part of the solution for lower category S&C, but I don't think we're confident enough in composites yet for high category, high speed stuff. noting that they're only just starting to look at 125 mile/hour trials on plain line with composites, and that's only on the fibre reinforced foamed urethane. Try saying that drunk. And that is clearly not as sustainable as something like recycled plastic, but it needs to be reinforced with glass fibres to give it the structural stability it needs. So yeah, we're looking at alternatives, but not for high speed turnouts at this time.
Thanks, Matt. I'm not a fan of using FFU myself. It's the acronym rather than the acronym.
A few comments online there. So Matt Thompson says, good evening, Matt. Thanks for the great presentation. Do you have any whole life cost projections?
Yeah, we do. They are unfortunately really complex because there are so many variables and so many factors at play. We've tried really hard to do this, but at the moment it tends to be quite qualitative rather than quantitative. It's based on reduction of shifts. So looking back to that Thirsk example, where we've been to Thirsk South half a dozen times, but Thirsk North we haven't had to worry about too much. So we can build up a picture based on avoided maintenance and avoided interventions, which is something. Because each site is different, it is really difficult to get a global picture together. So I'll happily discuss that one offline and share what we've got if people are interested in it. But we haven't been able to say, you know, it's 50% better whole life cost, because it's just there's too many variables and too complex to try and model that. But from what we understand is it should give us something in the order of 50% improved whole life for about 20% upfront cost increase. And that's 20% on the materials, not on the renewal. So it's around about 5% more expensive for a typical S&C renewal. When you consider the whole life, the whole system renewal costs.
Yeah. Excellent.
You've only got to avoid a couple of service affecting failures, and you make that money back in no time. You know, you've got trains that stand at Uddingston Junction. You're going to be, you know, racking up the delay minutes and the costs faster than you can get there and fix it.
Yeah, absolutely. Yeah. Okay, Fraser Bell's asking, how challenging is the CSM process for introducing new or novel layouts, particularly with the Unistar PoE?
So I think CSM is overstated in terms of how scary it is. And I think it depends who you talk to, but I've done CSM quite a few times now. And this will be my fourth kind of cradle to grave CSM program for a new product, doing the high-speed turnout stuff. And as long as you make a start early and you understand the scope of what you're doing, it's not that scary. You need dedicated resource, you need to take it seriously, but I don't believe it's the challenge that I think some people think it is, as long as you do it early, and that's the big caveat. I know we challenged Scotland a little bit, I think, with Uddingston. It came quite close to the wire with some of the CSM stuff, and I think we can all agree that there were lessons learned in both directions, both from the product development perspective on our side and also from the renewal itself. But yeah, it's a challenge. It's a challenge that we're capable of meeting, but it's all about early intervention and knowing the scale of the problem before you start.
Excellent. Phil Ransom's asking, do you or are you intending to include a smart or remote monitoring in the design? So the design will have remote monitoring built into the PoE, so we'll be able to predict failures. It's a hydraulic system, so by monitoring pressure, we get a much clearer idea of performance. So just going back to that slide. Sorry, where's it gone? Yeah, so this is the kind of thing you get with a pressure monitoring system, which you just don't get with current monitoring. So this is another battle that we're going through at the moment, is trying to persuade our signalling PoE RCM friends that pressure monitoring is what they want rather than current monitoring. It's slightly harder to implement, but the resolution of the data you get, because you get an absolute comparison of operating pressure versus stall pressure. So that will be built in from day one for the switches and for the swing nose.
And then in terms of the track element, I would hope that by then our S&C intelligent infrastructure stuff, things like the Connex trial we're working through at the moment, and there's another product out there called Swix, which does a similar thing. They will be available as kind of bolt-on. So while they're not inherent to the design, the idea is that there'll be a modular system that we'll be able to implement if the demand is there. And I think for a gold-plated asset like this, would be daft not to, because the resolution of the data we get from Connex is very, very good. You know, we can switch it on and overnight we know we've got 5 min avoiding, or you know, it's the degradation rate is predictable from the software they use. So it's a really good tool, and I think for the cost of it, it will be a no-brainer on someone like Handsaker.
Excuse me, another one from Dave Pete, who's asking foreign geometries would also not, or comment, sorry, not a question maybe, foreign geometries would also not be directly able to replace 56B geometry.
Yeah, that's correct. Yeah.
So, yeah.
And that was another reason why we were unable to go for an off-the-shelf foreign solution for high-speed turnouts as well. So in theory, you could just go to France and say, I'll have one of your high-speed crossovers, please. But because all of their crossovers are designed around a wider interval, 3 meters rather than the 2 meters that we have, or give or take, the geometry doesn't work. You can't cross over at the same angle when the interval is different. So if you're going to be ripping up the rulebook and changing the geometry, it's worth looking at what else you can change at the same time to improve reliability as well. A common question in the early days of high-speed turnout was, you know, why are you reinventing the wheel? Just buy what they use in France, but we can't because the track intervals are different.
Excellent. That's all the questions on the chat. I don't know if there's any more in the room at all.
A couple of questions.
Yeah, go for it, John.
Yeah, it was just a couple of system questions. I apologise, I'm not familiar with the system at all. I was just wondering which stressing system, I suppose, or stressing lay one in the kind of discussion. Is it a ball and claw design, or is it a stress transfer block design?
It's neither. So the intention here was to move away from stress transfer blocks because we believe that they can introduce geometry faults where they're installed incorrectly or where the stress migrates over time. So the intention is no blocks, and the ball and claw I don't think is a particularly good solution because it allows movement and creep up to a certain level, but then it bottoms out on the ball and it snaps off, and you've got a potential switch failure because you've got a broken bit of steel bouncing around. So what we use here is a floating free switch tip, and essentially you've got a hole. It's very low tech. It's a French design. Actually, we pinched it from them. You've got a hole in the stock rail here, and you essentially you sight through and you look for the switch tip through the hole, and you set it according to temperature. So 27 degrees, you'd expect the switch tip to be central to the hole, and then colder further back, hotter further forward. So you don't stress the switch. Obviously, the free length of the switch isn't stressed, but everything else is stressed as per a ball and claw layout. So you stress the closure rails and the gut rails if they're long enough, but otherwise it's broadly similar to a ball and claw approach, but without the risk of an incorrectly set ball and claw, which is quite common from what I've found.
Just one last question. Did you do any kind of developments in insulated joint technology? Seem to have thought of everything.
So IRJs, we have left them for now as off-the-shelf solutions are adequate. We looked briefly at scarf joints, which Network Rail as a whole has been looking at scarf joints for a while. These are the ones with a 30-degree cut, so the wheel sees less of an impact. So while they would be compatible with the Mk2 S&C, we haven't yet implemented those, and subsequently we've had some difficulties with them because they're quite difficult to inspect and test ultrasonically because of the way that joint works. I would hazard a guess that IRJs are becoming less common as we move towards modern axle counter signaling systems. So we haven't seen it as essential in terms of S&C reliability as a low-hanging fruit that we wanted to tackle. If the data suggests otherwise, then we can certainly look at it. But at the moment, it's a case of existing products are compatible. Improved products will remain compatible. as long as we don't do anything daft with clipping arrangements and the fish plates that support the thing. But that's what we've got to so far. So in a word, no, but existing and future enhancements should be compatible.
Mark?
How you doing, Matt? Having been the project engineer for the Uddingston job, it's quite satisfying to know that there's no real sort of problems have come back. So I think that's a sort of credit to our installation colleagues at Babcock and our design
Absolutely,
friends
yeah.
at Arcadis. So the one thing for me was at the time was the provision of spares. I mean, a set of
Yes.
the 8 switches is massive to try and find an area to lay down. And I suppose that's the same for Stairs Junction just now. It's that first of type spare.
Yep.
I mean, to me, that's effectively saying that we don't have any confidence in what we've actually provided, that we need to provide a spare set to be floated in at some point in time.
Yeah, so that's an entirely risk-based approach, and I don't think there's any risk of these things failing overnight. But if we have a run through, if we cripple a switch when we're lifting it in, if somebody drops a weld next to it and does some sort of defect to the switch rail that can't be recovered, what are you going to do? So we've said from day one to de-risk that if this is a critical junction, and they're not all critical. Some of them you could live without for a few weeks or a few months. If it's a critical junction, provide strategic spares, and that seems to be the most robust approach from an ops perspective. We should be starting to row back on provide strategic spares for every layout, because we should be at a more mature position with route services now, whereas if you do have a defect overnight, you can get a replacement short lead time, and that's a whole other kettle of fish that I don't want to open in terms of route services, strategic spares, and response times. You know, lead times have been bad in the past. I think they're improving. We're working a lot better with supply chain than we used to, perhaps, and I think ultimately it needs to be a route asset manager's, PRE's decision as to whether he wants strategic spares or not. We should be providing better information for you in terms of lead times, and if you do have a defect, how quickly can you turn around a replacement? That's the sort of data that, that's kind of classic purchasing stuff. You know what your lead time is for something you're buying, and that would allow you to make more robust, more efficient decisions rather than always providing one of everything, which is the current philosophy. So yeah, if we can provide more information to support that, then we absolutely should, and we will.
So what would be an ideal shelf life for 8 switches at Uddingston before they become effectively redundant or obsolete or not required or effectively so corroded or scrap?
As in the shelf life of the spares themselves?
Yeah, for actually sitting out on site.
Well, I mean, they sit out on site when they're in track, don't they? So as long as they're adequately supported, we don't need to worry about protecting them from the elements. We need to make sure we're not going to rob them and pinch bits and pieces for jobs, which seems to be a challenge. Obsolescence obviously will occur. We might change a slide plate component or a clip component, but that can be managed with replacements as and when. It's all a balance of risk, isn't it? So I don't want to put a time stamp on it, but I don't see why they should be, going off after 5 years, 10 years. They should be as good as the day they were built, as long as they've been looked after. And I think a lot of it is around, robust and mature provision of maintenance of the spares. And it's a difficult thing when we can't even maintain the asset, but little things like making sure where they're laid down, they're supported adequately along the length, making sure they remain banded, stock to switch. Yep. I've seen these things chucked on a pile of ballast with a massive great bow in the middle, and that's no good to anybody. So as long as we're designing this stuff in and we're doing whole life cost engineering, common sense, I don't see why they shouldn't last as long as the asset.
Thanks for that. Thank you.
I don't know if anyone online wants to come off mute and ask, or feel free to type the question in the chat. We can ask. Don't know if there's any further questions in the room. Anyone? Okay, last call for any questions online or in the room. All right. Nothing else. I'll just move on to the vote of thanks then, Matt. So really, just to say thanks for an excellent presentation. It was clear, as you said at the start, it's a labour of love for you, having worked on it in the last 7 years, and that came across because you covered absolutely everything on the topic. And it was great to see the timeline. I think that was really important to see the development of from NR60 to where we are now with the NR60 Mark II. I think it's important for people to hear and see the work that goes on, what we think was behind the scenes on the design and development and the testing, and then all the way through to approvals and assurances. A lot of work goes into these things before they land on the ground. The Thirsk case study, again, we mentioned, it was good to see that as actual evidence of must be quite reassuring for yourself that Mark II is performing better than Mark I. And a good point you raised regarding the failures that cropped up, and the reminder that most of those failures are related to perhaps, not so much installation, maybe ongoing maintenance, and it's the same as any other asset. It needs to be looked after as well. And the other challenges you mentioned, updating standards, getting people to accept the new fastening systems, etc., all things that are ongoing. Definitely, as Mark said, having worked as well on other things, a relief to hear no failures in Scotland. And again, big shout out to the design team and the installation team from Rail Systems Alliance as well. And also good to cover the next steps as the further rollout of NR60, including in some lower categories of track. And then the next big thing is going to be the higher speed turnouts, crossovers for 100 and 125 miles an hour. All great. Lastly, you mentioned you're working with some manufacturers abroad and looking forward to site visits. I don't think you'll be able to beat Christmas Day in Uddingston, though, and compared to any of them. So, just to wind up and say thanks very much, Matt, for doing this. It's much appreciated, and I'll ask everyone in the room to join with me and thank you for that. Thank you.
A pleasure. All right, thank you very much for having me. Always keen to share the S&C love. So just get in touch with anything else anyone wants to know about, and take any questions offline.
Cheers, Matt. Thank you.
Brilliant. Thanks, guys.
Thank you.
Thank you very much.
They're also sausage. Excellent.